Hey everybody, welcome back. This is Michael from Second Revision, and again we have our Arduino board here. Today we're going to be going over discrete inputs and outputs. As you can see from here, we still have our LED blinking from our first Hello World program, and we kind of already went over how to make an output turn on and off. So we're going to review that really quickly. So here on my screen, I have the LED blink program that we were showing the first time that we decided to do our Hello World. And here we have some of our key points. With a discrete output, the key functions we're going to use are pin mode and digital write. So when we wrote this script, we had pin 13 is attached to the LED on our Arduino board. And what we had to do is declare pin 13 as an output. So you can see that we did that here in our setup function. And initially, we wrote pin 13 as low to turn it off. So it's that simple to turn an output off. And it's just as simple to turn the output back on. So what we did here was we wrote digital write pin 13 high, and again that turns the output on. So you can do that with any of the pins from 0 to 13 here, any of the pins on the header. You want to kind of stay away from pin 0, 1, and sometimes even 13 if you're using it as an input. But as far as outputs go, you can pretty much use every one you want. Now you want to stay away from the RX and TX again because those are our UART communications between our USB chip and our USB port here. And that is just a discrete on and off. So what I've done here is I've taken our blink program and uploaded it to the board. I can upload it again just to show you guys. Make sure that you have the correct COM port assigned. Because I have two sketches open. Huh. Never seen it actually show it twice. But COM3 is to this board, and you want to make sure that you have the correct board selected, which we have an Arduino Uno. And let's go ahead and upload that again just to show you guys. Uploading sketch and done uploading. So our blink program is uploaded, and what I've done here is I've hooked up my oscilloscope to show you that. So we're blinking on and off on the LED, on, off, and in our code we have set to do it every 1 second. So I have hooked up the oscilloscope, and on the oscilloscope here it is showing that here's our 0 volt mark and here's our 5 volt mark, and every second it will turn on and off. You can see the divisions down here. I have them on seconds, and we can actually see that happening every second. So that it's kind of nice to be able to see it happen. So what we're going to do is we're going to take our blink program. Let me save this as a new name. All right. So what we can do is we can go ahead and we can change these times like we did last time. Upload it again. Done uploading. And then if we go ahead and look at the oscilloscope, now with our 1 second divisions, we can see here that it turns on and off every half second, the same as we changed it in our program. So that's just kind of nice to be able to see what's going on there. So that's how you would do a discrete output. We'll go over the pulse width modulation a little later on some of the pins here that have the tildes next to them. Those are the PWM pins, and we will go over those later. Next, we are going to go over discrete inputs. So if I open a new sketch here, and what we can do is, so we use the same function, pin mode. We use pin mode before to write an output. We're going to do the same thing. Let's use pin 2 and declare it an input. So pin 2, we're going to declare an input. And let's start our console. And we're going to write a little test scenario here so that we know if the pin is on or off. So let's go ahead and so here's a new function that we can use. Actually, we used this the first time also in our Blink program, which was digital read. And this is how you're going to read a digital input. So if digital read pin 2 is high or true, let's go ahead and output, let's write to our console that we know to tell ourselves that it's high or true. So basically, if pin 2 is high, we're going to print in one line to our serial console here, our serial monitor, in string form. That's what the double quotes means. It's a string. We're going to say pin 2 is high. And then we're going to go ahead and say else, which in this case, since it's discrete or binary, we have on or off. Else just means that the pin is not high, it's low. Let's go ahead and tell ourselves that the pin is low. And we can go ahead and upload that sketch. Let's save it and upload it. And basically all I'm going to do here is I'm going to take a jumper wire. I'm just going to take a jumper wire, and I'm going to use our 5 volts and our ground pins here. And if I start off with our 5-volt pin and take it and place it in pin 2 and go back to our serial monitor, we have pin 2 is high. Now if I take it and if I change it from 5 volts to ground, pin 2 is now low. So that's just telling ourselves it's high, it's low. So we're reading the pins. And all I did was move this yellow wire to ground here. So I can move back and forth between 5 volts and ground, and we'll get high or low. Now, when you're using an input, these are high impedance inputs, and when you declare an input, it's basically what's called floating. And so what you need to do is you need to use a pull-up or pull-down resistor or connect the pin to a device that drives the pin low or high. You don't want to just leave a pin floating, as you'll get erroneous inputs. And then you'll sit there and bang your head against the wall and wonder why your code isn't working. So they have what are called pull-up and pull-down resistors. Now you can use external pull-up and pull-down resistors and tie them to your breadboard or whatever you would like to do. And pull-up and pull-down resistors are usually 10 kilo ohms, 50 kilo ohms. You want it it's what's called a weak sway to one direction or the other. You don't want it to be too low of a resistance value, or whatever's driving your pen will not be able to overcome the pull up or pull down resistor. And so what Atmel has done with these chips is provided a nice way. They include an internal pull up resistor. So what we're going to do is we are going to look at that real quick here in the schematic. So you guys need to keep looking at your Amiga 328P schematics and the manual. You'll find all kinds of information here on, let's see, page 59 of this manual, section 13.2, ports as general digital I/O. And basically all I want to show you in this complicated circuit is this right here is our pull-up resistor. And if we declare our input, our pin as an input, and we enable the pull-up resistor, our pin will be pulled high to our VCC, which in this case it's 5 volts. We're using the Arduino board is designed for 5 volts, so it'll be pulled up to 5 volts. Another thing I want to show you guys is page 259. Nope, wrong number. 259. They go ahead and tell us that the I/O pin pull-up resistor has a value between 20 and 50 kiloohms. So if you need to know for current reasons or anything like that, if you're trying to calculate current for a certain device, your pull-up resistor will be between 20 and 50 kiloohms. So that is good to know, just to show you that it's just kind of a weak pull-up value. So what we can do here is, so before we just declared pin 2 as an input, and then we just read if it was high or low. And if I do not, if I just let the pin float here, and I go back to our oscilloscope, we are floating above 0 volts here. You can see we have an RMS value of 600 millivolts. We're just kind of floating. And other things, if you have a larger circuit, other things can pull this pin up and down. So really, you really need a pull up or pull down resistor or something to drive it. So if we go back to our sketch, to enable the pull up resistor, what you want to do is declare the pin as an input, and then we want to go back to our function, digital write, and we want to declare pin 2 as high. And so it's a two-step process to enable the pull-up resistor. First, you want to declare the input as the pin as an input, and second, you want to declare it high. And what this does is it enables the pull-up resistor. So right now, I haven't uploaded this yet, so basically this is not being activated. If we look at our serial monitor, it's saying pin 2 is low. So I'm going to go ahead and enable the pull-up, upload, and our serial monitor now says pin 2 is high. And if I pull our oscilloscope back up, and we are, once it updates, we're at 5 volts. So our value here is 4.962. So our pin is being pulled up, and I can ground our pin And there we go. It took a second to update. And if I ground our pin is at 0. And our serial monitor here is pin 2 is low. So it takes a second to update going from my oscilloscope to my computer. If I remove the ground, pin 2 is now high on our serial monitor. And it takes a second to update. And there it is, 5 volts on the oscilloscope. So that is how you declare a pull-up resistor. So again, you do not want just floating inputs in your project. It will cause you all kinds of headaches. Another thing I want to go over real quick, if we go back to our discrete outputs, I want to mention some electrical characteristics of the discrete output pins. So you can drive things with these output pins, but they're mainly used for logic. So you don't want to drive anything too powerful. If you want to drive something more powerful, such as a lot of LEDs or motors or things like that, you're going to have to use transistors and MOSFETs, and we can get into all that stuff later. But I want to show you real quick in the data sheets some of the characteristics here. The absolute maximum ratings of the chip, there's 2 important values here regarding the digital or discrete I/O pins that we're talking about. One is DC current per I/O pin. So this is syncing or sourcing. You do not want to go above 40 milliamps. Really don't want to get near 40 milliamps, but you don't want to go above 40 milliamps per pin or you'll fry your pen. Then that pen just won't work anymore. Your chip might work still, but that pen will probably be damaged. The other maximum rating they give here is the DC current for the VCC and ground pins is 200 milliamps. So total, whole chip, you don't want to go above 200 milliamps. So if you're thinking, oh, well, 40 milliamps, I can just use, I have 13 pins, 40 milliamps. No. You can't go above 200 milliamps per chip. And that's an absolute maximum rating. There's other notes in here. The sum of all current for the ports, C5. So when we're talking about ports, they're talking about there's ports, BCD are your discrete ports, and so they're talking about individual pins on your chip here. The sum for C0 through C5, D0, G4, you don't want to go above 150, and then the sum of the rest of them, you don't want to go above 150 milliamps. So there's other stipulations. So basically, if you want to use the board to drive anything major, you want to use transistors or MOSFETs, but that's just another note I wanted to go over here. Regarding the discrete outputs. So that is just kind of a quick introduction to reading and writing to pins. I'll post this code online. Again, this code was our Hello World program and our console program, and then this is just the complementary input code. So if you liked this video, go ahead and give it a thumbs up. If there's stuff you guys would like to see, please leave it in the comments and ask me and I will show you. Go ahead and hit that subscribe and that notification bell to be notified of our new videos. I'm going to try to keep going on these Arduino videos, and hopefully we'll get into a lot more complicated topics, and hopefully we'll make something really cool. So thanks for watching, guys, and I'll catch you later.